Hey AP students, I just wanted to take a quick pass at the study guide just to see, just kind of make sure that we're all on the same page and things make a little bit of sense, and maybe do some free body diagrams in either this video or a later video. So as you know, we're covering three topics, which is accelerated motion in one dimension, accelerated motion in two dimensions, which includes launching things off tables and doing projectiles, and then finally we got forces in motion that we're going to be taking a look at. I put some things in the study guide and I wanted to just kind of highlight some things that I thought might be helpful as I was taking a look at writing the exam. So these kinematics formulas, we talked about this in class, how this is how the AP gives them, and you might need to adjust those for things like gravity, where you swap out A and instead put G for the acceleration due to gravity. Please remember, on the AP exam, always use G as 10 meters per second squared. It'll save you some time. Of course, if you use 9.81, that's totally fine. Like you're not in trouble if you use 9.81. It's just easier to use 10. We talked a little bit about the kinematics equations in two dimensions, how what they actually give you is this. But of course, you're going to need to modify that for constant velocity in the x direction with acceleration in the y. Remember also that the time you spend traveling in the x direction is equal to the time you spend traveling in the y. And so when you work out two-dimensional problems, you end up solving for time and substituting into another equation. Those kind of things I find to be useful. Again, with projectile motion, these are the equations they give you. And what I did on this page here was actually kind of show you how to come up with those equations. So for example, you might do V naught cosine theta in the x, V naught sine theta in the y. And then when you want to calculate the maximum height, for example, you can use equation 2, v squared equals v naught squared sine squared theta plus 2 or minus 2gy. When you isolate y, that's the maximum height. You end up getting v naught squared sine squared theta over 2g as your height. Similarly, if you want to get the, if you want to get the hang time, you can actually use v equals negative gt plus v naught. And here we're going to actually get 0 at the top equals negative gt plus v naught sine theta. This will give us half the time to just get up to the top, and we'll double it to get the time going down. When we actually do that, we're going to end up getting this little guy right here. And then finally, to get the maximum range, since we know that the time is 2 v naught sine theta over g, and we know the formula in the x direction is v naught cosine theta times time, because there's no acceleration. This is just rate times time, basically. We're going to actually end up getting that the x formula for range is 2 v naught squared sine theta cosine theta over g. And we can do a little trig thing here just to note that x is actually equal to v naught squared sine of 2 theta over g. And if you notice, since sine of theta, sine of x, let's just say, is 1 when x is 90 degrees, that means we're going to get our maximum value for range when this is 45 degrees. So those are the things to know. This is a really quick derivation, and my expectation is that you're fairly comfortable kind of going through this. If not, you might want to go through it a couple times just to be safe. Couple things. I have a process for doing force problems that I find really useful. So you want to skim the problem to kind of get a feel for it. You want to draw a labeled free body diagram. You want to set up your x and y equations, and then you want to solve for your acceleration and constraint forces that we discussed in class. By the way, just a little life hack. Whenever I use the term net force, that's this left-hand side, but it turns out it's equal to m times a. So a lot of times, you're not all, especially in multiple choice, you're not going to get your net force by taking a bunch of forces and adding them together. You're actually going to take some kind of given mass and times it by an acceleration that they give you. So kind of look for that in multiple choice section. So that really kind of sets us up for running through the basics of this study guide. You can kind of look at it on your own and sort of use it to sort of reassure you. I don't know if there's a lot of physics in here, but it's just kind of a map of what we've covered so far. In the next video, I want to run through a few free body diagrams and maybe a couple of equations on this page here.